Hey there, everybody. This is Mr. Sheeline. This is going to be the video designed to help you determine what the chemical equation is from a word problem. So this is going to be, or this is a worksheet that you can find on Google. It's not going to be associated with the homework that's going to be due, or that that you need to complete for today. This is just to kind of walk through what it is and what words that you should find in order to create chemical equations and then eventually to balance them. So in this video, it's just going to be picking out the words that you should be paying attention to that will help you design the equations, not so much of the balancing. There's two other videos that I'll have prepared and ready for you with the assignment covering that. This, I just want to walk through these word problems and just really and point out all the different words and phrases that help you identify the different parts of the chemical equation as you're writing them out. So let's just get straight to it. Okay. So as it says here, for each of the following, if this were to be a worksheet you would have to complete for me, write the chemical equations to describe the chemical process taking place, balance the equations. All we're going to worry about again is we're going to be worrying about more or less just laying out the chemical equation and getting it ready. So let's just take a look at number one. So what I'm going to do is I'm going to have the green represent the green pen will represent the reactant side. The red will be the product side of things. So let's go through number one. When lithium hydroxide pellets are added to a solution of sulfuric acid, lithium sulfate and water are formed. Okay, so when I read that, immediately what I see here is I see lithium hydroxide pellets are added to a solution of sulfuric acid, and then there's a comma, there's a pause. Okay, so this is telling me that some scientists, and I'm picturing in my brain, some scientists walking over and putting these pellets into this solution, and something's going to happen. So this tells me that lithium hydroxide, sure, you can say the pellets, but really it's the lithium hydroxide we worry about and the sulfuric acid. So those are going to be, because we're combining those two, okay, we're combining those two to see what happens. Those are our reactants. Okay, so again, R is green. Okay, those are our reactants. Now, because it says lithium hydroxide is added, or these pellets are added to the solution, and then that's it, that implies that that's the end of the reaction. So we would have the lithium hydroxide as with the whole sulfuric acid as our reactants. So anything after those two is going to be separated by our yield sign. So it would be like lithium hydroxide, which is LiOH, plus, and then sulfuric acid, H2SO4. Excuse the awful pen here. Oh, apparently I can't draw there. Okay. And then it's going to be separated by, again, our yield sign. Okay, the arrow. Man, what is with my stylus? Yikes. Okay. So then again, remember, anything after that it should be implied that anything after that yield sign or this pause is our product. And let's see if that's true. So okay, so we've added the lithium hydroxide pellets to the sulfuric acid, pause. And it says here that lithium sulfate and water are formed. So lithium sulfate and water are formed. Now, what tells me that this is my product is specifically this word right here. When something's formed, something has been created, something has been made anew, that tells me that that's my product. Not only that, this pause here at this comma, that also tells me that this should be my product. Okay, so here lithium sulfate, so it's going to be SO4. Goodness, oh my God, that's aggravating. Wow. Okay, yikes. Maybe I'm going too fast. Oh my God. Okay, and then SO4, off the top of my head, that's a 2. Okay. So that plus our water. Oh my God, dude, come on. Yikes. So this is what our chemical equation would look like. Now we would then go and balance this. But remember, this video is just to help you kind of understand how it is that we break, or how we take this from word form and put it into equation form. Okay, and this is pretty much it. Something I didn't mention too, though, as far as the products are concerned, or sorry, the reactants. When you see words like added, or reacted with, those types of words are those words in your notes, those hints of how you know that one thing is, or how you know when things are typically the reactants. Added would be that word that tells you, oh, I'm adding the lithium hydroxide to the sulfuric acid, so this must be my reactant, or reactants, I should say. So that would be how I would set up number one. So let's take a look here at number two. So magnesium reacts with sodium fluoride to produce magnesium fluoride and elemental sodium. So magnesium reacts with. So another one here, reacts with. And here, actually, let's keep this a little. So reacts with, I'll underline it. Okay. Reacts with. So our our magnesium is reacting with sodium fluoride in order to make this magnesium fluoride and elemental sodium. So it's to say that this stuff right here, the magnesium, mixes with this stuff. Okay, so telling us those are our reactants, and then here to produce. So to produce, that's indicating our yield sign, but it's also indicating that anything after to produce, which would be this magnesium fluoride and sodium, are our reactants. So, okay, so then because we know now what our reactants are, what our products are, let's just write it out. So magnesium, so just magnesium, Mg, reacts with sodium fluoride, so that'll be NaF, okay, to produce, okay, magnesium fluoride, so that's going to be Mg, MgF2, okay, magnesium fluoride and elemental sodium. And just the word like elemental just means that it's just pure sodium. So Na, that nothing more. Okay. And so we would take this and we would go balance it. But, again, that's not what this video is here for. But here we would have our complete chemical formula. We would then have to move on to balancing it. So, okay. So let's keep on trucking. So let's take a look at number 3. Okay. So if a copper coil is placed in a solution of silver nitrate, silver crystals form and copper 1 nitrate is generated. What's cool about this example real quick is that this is actually a lab that we do, that we normally do. And it's that one I may have mentioned to your class about Mr. Hamer and I figuring out if we're able to complete it or not. It's a really cool lab, but it takes us like a whole week to do it under normal circumstances, and we're still trying to work out the details to see if we're able to do it when we come back in person, and if we're able to somehow manage that time, space, and resources in order to complete it. It's looking like a no, just so you know, as of right now. Unfortunately, just because looking at how we would have to split the labs up, it just wouldn't work. But anyway, that's neither here nor there, I guess. Sorry. So if a copper coil is placed in a solution of silver nitrate, silver crystals form and copper 1 nitrate is generated. So copper coil is placed in a solution. So this is placed into. And we're talking about just copper here, mixing with silver nitrate. Okay. So, and then we have another pause. We have the comma. So that tells me I'm going to put the copper into silver nitrate to see what happens, and to see if anything forms after that, to see what's produced. And it says here, silver crystals form. Now, because those silver crystals are formed, okay, that means they're produced. That tells me that the silver crystals are part of my product side. and then the copper 1 nitrate is generated, tells me that that's on my product side as well. Okay. So copper coil, so that's just going to be Cu. Okay, Cu, and it's put into silver nitrate, so silver and then nitrate. Okay. Silver nitrate. Ooh, I better double check that right quick before I move on. So I know sometimes I get confused with silver. Yep, that's what I thought. For whatever reason, oh my goodness, sorry. For whatever reason, I always think that silver nitrate, or sorry, just silver. I always think it's a 2+. I don't know why. It's 1+. So my bad. So there's AgNO3. Okay, yields, forms, produces silver crystals, which silver crystals just straight silver, and then copper 1 nitrate. So that's going to be CuNO3. And then we would, again, go out and balance this. Now, it looks like to me, though, that this is pretty much balanced. So this would be one of those cases where everything's hunky-dory from beginning to end. We wouldn't have to balance it. It's already balanced. Okay. And then number 4, number 5, I've already made 2 videos on number 4 and number 5 as far as, writing them out and also balancing them. So I'm not going to do those. I'm not going to go nuts on that. But let's go down here. And I've already done, let's see, I believe the zinc and lead, I did that, and the aluminum bromide chlorine gas. I think number 1 and number 2 I've already done. Now, we won't go through all of these, but I will go through, I don't know, let's go through the next 2 or 3. So just to really nail it and hammer it home. So looking at number 3, so sodium phosphate and calcium chloride react to form calcium phosphate and sodium chloride. So again, we've got the word and here. We've got sodium phosphate, calcium chloride, react. Okay, so that tells me that these two were mixed together. These reacted together. It was the first thing that happened. And then afterwards, things were formed. And what formed? Well, what formed was calcium phosphate and sodium chloride. Okay. So again, just to write these out, so sodium phosphate, so that's Na, that'll be Na3PO4. I didn't need to put the parentheses, but let's just redo that a little bit. Na3PO4, and that mixed with the calcium chloride, which that's going to be CaCl2. And then that produced calcium phosphate. Well, now we'll need parentheses. Calcium phosphate, and then sodium chloride. Okay. And sodium chloride. And so this is, again, here we have our equation. We would then go ahead and balance it. As we can see, it's not 100% balanced. Okay, let's just do one more. I think we're starting to get, we should be getting the picture by now. Let's just do one more. And instead of number 5, let's see if there's a better one that I can do. Copper, silver. React. Yeah. I guess there isn't one on here that I would want to. I'll just say, we'll still do one more. Here's what I'll say, though, is that because I want to look for one of these two right here, like number 4, number 5. I highly recommend that you watch those 2 videos that I've provided to you to help out with these word problems and also with balancing, because these 2 right here are technically combustion reactions, and just another, there are 2 other great examples to where you can better understand, the language used to describe chemical equations. But we'll do one more here. We're going to do number 5. Let's actually do number 5. Yeah, let's do number 5. So aluminum. So aluminum and hydrochloric acid react. Okay, so aluminum, hydrochloric acid, they react to form aluminum chloride and hydrogen gas. That's kind of weird. Hydrogen gas, I don't know how you write that. How do you write that? Well, let's just kind of walk through it. So aluminum, which is just going to be Al plus hydrochloric acid, so that's HCl. Okay, HCl. These guys react to form, so this yields, and then the aluminum chloride. So aluminum and then chloride. Okay, AlCl3. And then hydrogen gas. So remember Hofbrinkel. Always remember Hofbrinkel. In a lot of cases, it will have the word gas at the end of it if it's indicating that it's indicating it's a diatom. Sometimes it doesn't. Sometimes there are problems that would just say, it would just look like this. It would be aluminum and hydrochloric acid react to form aluminum chloride and hydrogen with no gas at the end of it. And what you have to remember is that hydrogen, oxygen, bromine, iodine, chlorine, fluorine, all those guys in Hofbrinkel, they are diatoms. So they naturally float around in groups of two as molecules that have two of the same elements. So we have to make sure we write this correctly. Oh my goodness, these stylus. Come on. This is ridiculous. Jeez. Maybe I gotta clean my screen. I don't know. Man, it's aggravating. But anyway, and then we would have here with H2, we would have the equation, and again, we would then have to balance it. So, okay. So what to expect? So remember, break down the word problems with the language that's used in the problems. Identify what are the reactants. Identify the products. Understand where the yield sign, the arrow will be placed, and make sure you actually place it in your actual formula, in your actual equation. Remember your diatoms. So Hofbrinkel, don't forget Hofbrinkel. Okay, write it down. If you've got to write it down somewhere to remember that all the different elements that naturally are formed in pairs. You've got to remember those guys for the test. Okay, you have to. So those are the things to remember. And on top of that, lastly, what you have to remember is you just have to remember what we studied in all of Unit 3. Look at the names of these particular chemical formulas. Write out their formula form, and then after you've properly written out their formula form, put it into the equation, balance the equation, and then we're good. Okay. So if you guys still have any questions for me, make sure you ask those questions. Either email me, send me a text on Remind, send me a comment in Google Classroom, whatever it is. Make sure you get a hold of me. Also, remember to check Google Classroom for my office hours while we're in full remote, if you're wondering what those times are. So anyway, guys, that's going to be it for the video. If you still have questions, remember, make sure you get a hold of me. If not, thank you for watching, and I'll see you in the next one.